Alright, today we're going to talk about completing the square. Now, before we do that though, we're going to do a little bit of a warm-up here. What I would like to do is factor this trinomial right here. So take a moment and do that. The way I would look at it is I would see it as this factors. X plus 11 times x plus 11, or x plus 11 quantity squared. And then this one over here, this one I would factor x, and I would use minus 12 and minus 12, or x minus 12 squared. And so if you notice, both of these, they end up having factors that are identical to each other. And these are called perfect square trinomials. Anytime that you have a trinomial that gives you factors that are identical, they are called perfect square trinomials. And that's kind of going to be an important part of today's lesson. So let's see if we could actually come up with a perfect square trinomial. So here I have the beginning of one, and I want to know what number would I have to put here to make this a perfect square trinomial. Well, in order to do that, maybe we should look back up here. What kind of relationship does this number and this number have? Well, it might not be obvious to you. It's actually kind of sneaky. And the way these two numbers are related is you take this number, 22, if you divide it by 2, which is 11, and then if you square that, you get 121. Same thing with this one over here. If you were to take 24 divided by 2, you get 12, and then square it, you get 144. So to finish, or to make this a perfect square trinomial, we would just take this number 2 divided by 2, which is 1, and then 1 squared is 1. Okay, so a 1 right there would make that a perfect square trinomial. And how do I know that? Well, if I were to factor x and x, factors of 1 are 1 and 1, and there you go. Alright, what about this one? We'll take 8 divided by 2, which is 4, and square it, 16. There you go, it's perfect square trinomial. And again, just to check, you'd have to do x, and this would be 4 and 4, and yeah, it is. Well, why are we going through this? What's the whole point? Well, the point is this, that when we're doing all this solving of quadratics, and we have learned that you can either solve a quadratic by factoring and using the zero product property, or you could do it by the square root method. Those are the two ways that we've done it so far. Well, what if you have a quadratic that factoring and square root method don't work? Because it'd be great if both those two methods always worked, but they don't always work. So because of that, we need to come up with a plan, a way to still solve it, but not using those two methods. And that's where we have this new method called completing the square, which is kind of shortened for completing the perfect square trinomial. And it's several steps long, but the nice thing is I'm going to give you a whole list of steps, and this is something that you're going to have to practice and you're going to have memorized. Okay, so let's try this one right here. Now, if you looked at this one real closely, you would notice this one actually does factor, and we could solve this by factoring, but we're actually going to do it by completing the square just because I want there to be a fairly easy example to start with. Okay, so there's 7 basic steps. Now, the first step we're going to skip for now. Okay, and so we're going to jump right to the second step, and I'll explain why we're skipping the first step here in a second. Okay, so the second step is we're going to move the constant to the right. So as I look up this at this trinomial, the 12 is the constant, so I'm going to move it over here. So I'm going to subtract 12. So x squared plus 8x plus, now there's a big blank right here, so I'm going to leave it as a big blank. Alright, so that's the first thing. Just get that out of the way. Okay, second step is we're going to complete this. We're going to try and create this into a perfect square trinomial, just like what we did up here. Okay, we're going to try to fill in a number right here that would make it a perfect square trinomial. So how do you do that? Well, I gave you the 2 steps earlier, but I'll write them down anyways. And that is, you're going to take your b value, okay, that's this number right here. Okay, that's based upon this, ax squared plus bx plus c, so this value. So divide b by 2. And then we're going to, fourth one is square the answer, square it. Square that answer. So exactly what we did up here. So we're going to take 8 divided by 2 and square it. Okay? So when you do that, we're going to put that right there. Okay? Which leads us to the 5th step, and that is you have to add that answer to both sides. Now, why do we have to add it to both sides? Well, we have to add it to both sides to keep the equation balanced. So we can't just add 16 to one side and not the other. So we also have to add it over here. Okay, so done that. So what's the next step? The next step is we're going to factor to left. Okay, so let's factor this. So that would be x plus 4 times x plus 4. And we're going to simplify the right. So just basically combine those. So I get 4. Okay, and then the last step is just solve. Well, how the heck do I solve that? Well, you notice that these are the same, so I could write it like this. X plus 4 quantity squared. Well, hopefully that looks familiar. That is just like our last section, which was square root method. So how do I do that? Well, I'm going to square root. So that becomes absolute value of x plus 4 equals 2. So that becomes x plus 4 equals plus or minus 2. So that becomes x plus 4 equals 2, and x plus 4 equals negative 2. And simplify, I'm going to subtract 4. So I'm doing this all at once. And so this one, sorry, I'm running out of room. I'm going to put the answer over here. X equals negative 2. And then this one over here becomes x equals negative 6. So there's my 2 answers. Okay. So completing the square, 7 steps. Now we didn't do the first step, which isn't that big of a deal, but we'll show you when you have to do that. But once you do it a few times, it actually becomes quite easy. And the thing is about completing the square is you can always do completing the square. You can't always factor, and you can't always do the square root method, but no matter what type of quadratic you have, you could always do completing the square. Okay, let's move on to the next one. Alright, so I already had the steps over here. We still have our blank for the first step, but again, we'll come to that here in just a minute. So let's actually try this. So first step, well, after we skip the first step. So second step, move the constant to the right. So I'm going to subtract 14. So we get x squared minus 10x. Got a big old blank right there. And I also like to put the blank on this side, so that way it reminds me that I need to fill in. So this number, remember, that's our next 2 steps here. Divide by 2 and square it. So divide by 2, that's 5. 5 squared is 25. So I have to add that to both sides. Okay, down here to the 6th step already. And that is factor to left, simplify the right. So factor to left, so that becomes x minus 5 and x minus 5. And over here, that becomes 11. And if you did this right, this should always work out to where they're the same. Last step, solve. So I'm going to rewrite this as x minus 5 squared equals 11. Square root, absolute value of x minus 5 equals Now square root 11 can't simplify, so it's just going to stay square root 11. So it becomes x minus 5 equals plus or minus root 11. So it becomes x minus 5 equals positive root 11. X minus 5 equals negative root 11. Last step, add 5. Can't combine them, so it just becomes root 11 plus 5. And this one over here becomes x equals negative root 11 plus 5. And this is the type of problem why square root method is important, because this is factoring wouldn't work up here. You couldn't come up with factors of 14 that would add up to negative 7. And that's because there aren't any whole number or integer factors that would make that work. They have these radicals in them, so that's why it's really important. Okay, let's move on to the third one here. So what I need you to do is hit pause and give it a shot, and then once you unpause it, let's see if you got the right answer. Alright, so I'm going to go through the steps a little bit quicker since now you know what the steps are over there. My first thing is I would add 15. X squared plus 7x plus something. Now, this one's a little more difficult. It's 7 divided by 2. Now, that doesn't divide. But then you have to square it. So what do you get? You get 49 over 4. Ooh. Alright, so 49 over 4. 49 over 4. Alright, so then what do I do? Well, now the next step is I'm going to factor the left, simplify the right. So how do I factor the left? Well, what are the factors of 49/4 that add up to 7? Well, it sounds really difficult, but it actually is not. And that if you go back up here, and if you notice, what do you notice about 5 and 25? Or better yet, 5 and 10. Well, 5 is always half of 10. Same thing if you go way back to this example. You notice here that we have 4 and 8. 4 is half of 8. Okay, and that process is always true. Now these numbers right here will always be half of this number. So if this is 7, that means this is 7 over 2. Alright, now what about this part? Well, I can't add those together. I get common denominators. Well, this is 15 over 1. So that means I got to multiply by 4 over 4. So I'll put this work over here. 15 times 4 is 70. And if I add those together, I get 119 over 4. Okay. Next, let's put these together. Okay. Next, square root. So I get absolute value of x plus 7/2 equals, now this one, square root of 119. I don't know what that is, so I'm going to leave it as square root of 119. But I do know what the square root of 4 is. It's 2. Okay, so that equals x plus 7/2 equals plus or minus root 119 over 2. That means x plus 7/2 equals positive root 119 over 2, and x plus 7/2 equals negative root 119 over 2. Last but not least, subtract. X equals negative, or pardon me, root 119 over 2 minus 7/2, because you can't combine those. This is a radical and this isn't. And do it over here. So x equals negative root 119 over 2 minus 7/2. So, oops, sorry, I didn't mean to be off the page right there. So not the prettiest problem right there, but hopefully after we kind of got through this little mess right here, you see that the steps are basically the same. Okay, well, I'm going to run a little bit out of time here, so what I'm going to need you to do is you're going to, once this stops, you're just going to go on to part 2, okay? I'll talk to you in a second.